Ever wondered how inheritance hierarchies among entity types are represented in EERD? It's a question that might have crossed your mind if you've dabbled in database design. The answer lies in the concepts of enhanced entity relationship diagrams, or EERD for short, and the inheritance hierarchies they represent. These diagrams are crucial tools in database design, allowing us to visualize and understand complex data structures. Within these diagrams, we find the concepts of supertype, subtype, specialization, generalization, and inheritance. These terms describe how different entity types relate to one another, forming a hierarchy of information that can be easily navigated and understood. This is the key to creating efficient and effective databases, ensuring that every piece of data has its place, and that the relationships between different types of data are clear and logical. Stick around as we dive into the concepts of supertype, subtype, specialization, generalization, and inheritance. To understand inheritance hierarchies, you first need to grasp the concepts of supertypes and subtypes. In the world of enhanced entity relationship diagrams, or EERD for short, supertypes and subtypes are key players. Think of a supertype as a parent entity, an umbrella term if you will, under which a number of related subtypes or child entities reside. A supertype is a high-level entity that generalizes several lower-level entities. It's like a broad category that encompasses a range of more specific subtypes. For example, vehicle could be a supertype, under which car, bike, and truck could be subtypes. The supertype, vehicle, carries attributes and relationships common to all of its subtypes. These might include attributes like color or manufacturer. On the flip side, a subtype is a lower-level entity that inherits attributes and relationships from its supertype. This is where the concept of inheritance comes into play. Using our vehicle example, the subtype car would inherit common attributes like color and manufacturer from the supertype vehicle. But it could also have additional attributes unique to it, like number of doors or type of fuel. Now let's talk about the relationship between supertypes and subtypes. The relationship is hierarchical. The supertype sits at the top of the hierarchy with its subtypes beneath it. This hierarchy is the backbone of inheritance in EERD, as it allows attributes and relationships to trickle down from the supertype to its subtypes. But remember, while a subtype inherits attributes from its supertype, it can also have its own unique attributes. This is what makes each subtype distinct, despite being under the same supertype umbrella. So, to summarize, a supertype is a broad category that houses related subtypes. Each subtype inherits common attributes from the supertype, but can also have its own unique attributes. This hierarchy of supertypes and subtypes forms the basis of inheritance in EERD, making it easier to model complex relationships and entities. Remember, supertypes and subtypes form the basis of inheritance hierarchies in EERD. Now that you're familiar with supertypes and subtypes, let's explore the concept of specialization. Specialization in enhanced entity relationship diagrams, or EERD, is the process of defining subtypes based on a particular attribute or set of attributes. It's like zooming in on a specific category within a broader group. Imagine you have a general entity type called vehicles. Through specialization, you can create more specific subtypes, such as cars or bicycles, each inheriting common attributes from the vehicle's supertype, like color or manufacturer, while also having their own unique attributes, like the number of wheels or type of engine. Now, specialization isn't a one-size-fits-all process. It can be based on either disjoint or overlapping constraints. In a disjoint specialization, each entity instance belongs to exactly one subtype. Think of it as a strict division. If you're a car, you can't also be a bicycle. The entities in each subtype are distinct and don't overlap. On the other hand, overlapping specialization allows for an entity instance to belong to more than one subtype. This is like being a student who is both a part-time worker and a full-time learner. In this case, the set of entities in each subtype can potentially overlap. Specialization is a powerful tool in EERD. It allows us to create more specific entity types that inherit properties from a common supertype. It helps in creating a data model that is detailed and precise, reflecting the intricate relationships between the different entity types. It gives us the ability to represent real-world complexities in our data model, making it a more accurate reflection of the domain being modeled. Remember, the goal is to create a data model that is not only accurate, but also flexible and maintainable. By using the concept of specialization, we can achieve just that. By defining subtypes based on specific attributes, we can create a robust and flexible data model that can handle the complexities of the real world. Specialization allows us to create more specific entity types that inherit properties from a common supertype. The reverse process of specialization is known as generalization. It's like looking at the world through a wider lens where we identify commonalities among several entity types and create a more general entity type to represent them all. It's about zooming out to see the bigger picture, the broader category that ties together a group of more specific related entity types. Imagine you have several entity types like novel, poem, article, and blog. Each of these has some unique attributes, like novel might have number of pages, while blog might have number of views. However, they also share some common attributes such as title, author, publication date. In this case, we can abstract these common attributes and form a supertype, say, written work. This process of abstracting common attributes to form a supertype is what we call generalization. Generalization, in essence, consolidates the commonalities. It's like saying, hey, these entities all have something in common. Let's put that commonality in one place, in a supertype. This not only reduces redundancy, but also makes the model easier to understand and manage. But it's not just about attributes. Generalization also applies to relationships. If several entity types share common relationships, these can be abstracted into the supertype as well. This way we maintain consistency across our model. There are two types of generalization, complete and incomplete. Complete generalization ensures that every instance of the supertype has been generalized into one of its subtypes. It's like saying every written work must be a novel, poem, article, or blog. On the other hand, incomplete generalization allows for instances that do not belong to any subtype. It's like saying there could be a written work that is not a novel, poem, article, or blog. So why do we use generalization in enhanced entity relationship diagrams? Simply put, it simplifies the model. It consolidates common characteristics into a single entity type, making the model more understandable and easier to manage. It also ensures consistency in attributes and relationships across similar entity types. Through generalization, we can simplify our model by consolidating common characteristics into a single entity type. Inheritance is the glue that binds our supertypes and subtypes together. This key concept in the Enhanced Entity Relationship Diagrams, or EERD, is the mechanism that allows subtypes to inherit attributes and relationships from their supertype. Let's take a closer look. Imagine a supertype as a blueprint, a general set of guidelines that outlines certain properties. This blueprint or supertype can be used to create more specific, specialized entities, which we refer to as subtypes. These subtypes inherit all the attributes and relationships of their supertype. Much like a house built from a blueprint will have the same basic structure, but can have additional features or modifications specific to its design. This inheritance mechanism not only streamlines the process of creating subtypes, but also ensures consistency within the model. By inheriting from the supertype, each subtype will carry the same basic attributes and relationships, providing a uniform foundation across the model. This uniformity is crucial in maintaining the integrity of the data model as a whole, but inheritance does more than ensure consistency. It also promotes code reuse. Rather than redefining common attributes and relationships for each subtype, these can be defined once in the supertype and automatically inherited by all subtypes. This reduces redundancy and keeps the model lean and efficient. However, while all subtypes inherit from their supertype, they are not restricted to these inherited properties alone. Each subtype can still have additional attributes or relationships that are specific to its own characteristics. This allows for both uniformity and flexibility within the model, accommodating the unique properties of each subtype while still maintaining a consistent base. In the world of database design, inheritance plays a vital role in creating flexible, maintainable data models. By leveraging the power of inheritance, database designers can accurately reflect the hierarchical relationships among different entity types within the domain being modeled. So, once we've established our supertypes and subtypes and understand the process of specialization and generalization, we can see how inheritance holds it all together. Inheritance promotes code reuse and ensures our subtypes correctly reflect their supertype's attributes and relationships. And that, in essence, is the beauty of inheritance in EERD. We've covered a lot of ground today, so let's quickly recap. We've discussed the concepts of supertypes and subtypes in enhanced entity relationship diagrams. Supertypes are higher-level entity types that represent a generalization of several lower-level entity types, while subtypes are lower-level entity types inheriting attributes and relationships from their supertype. We delved into the process of specialization, which allows for the creation of more specific entity types based on a particular attribute or set of attributes. We also explored generalization, the reverse process of specialization, where common attributes and relationships are abstracted to form a supertype. Finally, we touched upon inheritance, the mechanism that allows subtypes to inherit attributes and relationships from their supertype. These concepts, when well understood and applied, can help you model data more efficiently, creating flexible and maintainable data models. Thanks for watching, and remember, keep exploring and keep learning.